Okay, so we're doing today simultaneous equations. So when simultaneous equations is when we have we'll get a set of equations and with more than one unknown in it. So if you have two simultaneous equations, you can have two unknowns. So you can see here we've got, say, the x and the y would be what we normally see. So what happens, we're going to solve these using matrices. So what we say, when we've got, say you had your two equations, so what I mean by that, we might have, say, 2x plus 3y equals, 20, and then 5x minus 2y equals 15, okay? So that's what we're saying. Say we had two simultaneous equations like that. So here's what they're saying. So in this format, we'd have two equations, and you can see that this A would be like the number in front of, the X, and the B, and so on, and C and D, all right? So if we want to set up this in matrix form and solve them, this is the way we do it. So we write our first matrix, which is going to be a square matrix, and what happens is the numbers in front of your unknowns, so the numbers in front of, in this case, x and y, will be put in the first matrix like here. Okay? Then we say times. Then we'll put our two unknowns in this one in a column matrix like that. Okay? X and y. Now, why do I put x on top? Because, say, can you see in our equations, x is listed first. So x is on top, all right? And y is the second one. And then we write equals. You have equals, and it would equal the ending answers. So for this one, E and F. So that's this is a basic template. So just to help you out, so if I had that example above, I would have 2, 3, 5, and -2. Can you see? Because they're the numbers in front of those letters. So 2's in front of X, 3's in front of Y. So you can see this is the X's and this is the Y's. Does that make sense? Yeah? I'm just taking the numbers in front of the example I did up there. So then we write times, and I have X and Y are my unknowns in my equations up there. Sorry, it's a bit hard to see. And then I would write equals 20 and 15. So you sort of essentially can see this across here is the first equation, yeah? So, and that's the way we set it up. So if you go back, what we have, if I just called this matrix A, and I'm going to call the one I don't know, this matrix X, and I might call this one matrix E. So I'm just giving that a label. So we know that if I times matrix A by matrix X, I get matrix E. So that's what's written here. So I've written that out here. Okay, so we're going to look at that. Now, if you thought about it, if I had, say, for an example, if I had the equation something like this, if I had 2x equals 6, okay, how would you solve it? What do you do to solve that? What would you do? Yeah, we would divide by 2, wouldn't we? Yes? That's how you'd solve it. So if I go back and I look at that this matrix equation that I've set up, so if I've got A times, X equals E, because this one is our unknown, if I was going to solve it, wouldn't I could bring the A over, which would be dividing, yeah, and go like that. Okay, but we don't divide in matrices. What do we do if we want to divide?
Inverse.
Good. We times by the inverse.
Inverse it.
So because that's how we're going to times, we don't use divide, we times by the inverse. So the way we would solve it is the inverse, remember, is -1 and times E. All right, but we need to be really careful because order is important. So why have I chosen to put this at the front of the E is because it's at the front here, okay? So the inverse, if your unknown was after, like if the unknown was the first matrix times in with a matrix you know, it'll link. We'll look at that in a minute. So this is what it's explaining out here. So we saw that we had the two matrix A times X, and to solve it, we're going to divide, which means we'll use the inverse. So really, in summary, when we've got simultaneous equations, the way we're going to solve it is we're going to use the inverse and times it by that ending one. So if I was going to do our little example up here, the way, say I was going to solve this, I would go xy, because that's what I'm trying to find, and what I would do is I'd do the inverse of this one to the -1 times the other one, which was 2015. So you can do this bit on your calculator, yeah? And then you would solve that, and it'll give you an answer of x and y. So let's go have a look at that. The only thing we have to be careful of is that you won't be able to solve the simultaneous equations if the determinant of this matrix, this first one, if that determinant equals 0, you're not going to be able to solve it because you can't get an inverse if the determinant is 0. So that's what that's saying. So that means that the simultaneous equations can't be solved, and I'll talk about that in a little bit. All right, so let's go set up this example just so you know. So we're going to take, we did this one, this is the same as before. These are the numbers in front of it, and these are my unknowns, okay? And these will also be numbers that you know. So if we go to set this up, just so you remember the setup, if you're asked to set these set of equations up in matrix form, you will set it up like this, where you put the numbers, just like I said before, you do times, you'll have your unknowns in here, and then you'll say equals whatever those answers are. Okay, now if we have one with 3 unknowns, so can you look here, we actually have x, y, and z. So they are my unknowns. And so you're going to have, if you have 3 unknowns, you'd have 3 equations. So how do I set that one up? We just have a 3 by 3, yeah? And it will be A, B, C, all the numbers in front of the letters here. We'll times it by our 3 unknowns, which will be in order, so X, Y, Z. So you've got to remember these have to be all the X's, that has to be all the Y's, and they has to be all the Z's, and then it goes in that order, and then equals, we'll say that that's J, K, and L, okay? So there's setting up if you have 3. If you have 4, it'll be a 4 by 4 with all the 4 and all that, okay? All right, so let's go. This is just summarising this all again. So they say the equation, we saw that. We can solve that by using the inverse matrix. So here, yeah, inverse matrix. That's how we can solve. So just be careful. If they ask for the setup, you do that. If they ask for you to show, if you have to show the matrix equation used to solve, if you have to show that, then you will have to show it in this setup. You'd have x, y equals, now you'll have that the number 1 to the power of -1 times the EF. So if you're asked to show the equation how it's solved, you've got to remember that you need to have the inverse there, yeah? You have to show the inverse matrix. Okay, so let's go have a look at this. So here, down here, they want me to, the solution of this matrix equation is. So let's have a look. They've already set it up. So for me to solve X, Y, and Z, what I'm going to type into the calculator, I'll just write that in purple. What we need to put in the calculator is this first matrix. And remember, that's going to be to the inverse, so times -1 to the power of -1 times the last, what the answers are. Okay, so let's go do that on the calc. So we did that and we ended up with 2, -1, and 4. So essentially, I know that x equals 2, y equals -1, and z equals 4. So which one is the answer? B. Okay, so let's go. So this is showing you what can happen. So if you've got matrix equations where you have an unknown, so what I'm saying here is that this one, if you set up the scenario, this is the one you don't know, okay? And if you know what the other two are, so say you know what A is and you know what B is, so you know these ones. If you have to solve, can you see if you were trying to work out what matrix X was, you could simply do B minus A, wouldn't it? Because if you move this A over the equal sign, you minus. So there's how you solve. What if you have the scenario of if you have the X that you don't know here, so you don't know this one in the scenario, but you have these two. So how would you solve it? You do B plus A because you'd move that A over. If you have a scenario where, so what we're saying is you don't know this X, but you do know what that N is, that N is and that A is. So just in this example, you might just want to write that N is a scalar number. So that means it's just a number, it'll be like 3. So say for example, I'll just show you. Say I had 3 times matrix X equaled, matrix A. So I know this and I know the 3, but I don't know, say I don't know this one. This one's the question. How would I solve it? I would just go, because divide by 3 or times by 1/3 like that, okay? That's what that means. Now down here, this is the scenario of simultaneous equations, yeah? So this is simultaneous equations here. So we didn't know, when we don't know this one, but we know that we know the A and the B, this is how we solved it. Now this was the other scenario I was talking about. What happens if you don't know, X is the one in front. So this won't be a simultaneous equation. This could be a scenario that they give you where you don't know what this X1 is, but you do know this A and B. Now, because A was after the unknown, can you see how it's being times by the after that one? Its order is very important. So if you set up a scenario, you've got to remember that. It has to be after. All right. Okay, so there's a blank page. Let's go through these examples here. So use matrix methods to solve this simultaneous equation. So you can see when you don't have a number, remember that it's like a 1. So that'd be 1x, 3y, negative 2x plus y equals 4 equals 7. So you can see they've set it up. This matrix here is these numbers and the 1, it would have a 1 there. Then you've got x and y, so to solve it, they've typed it into the calculator, they've raised it to the power of -1 times it, and they'll get their answer Now, they either get an answer of fractions or decimals. You won't have any answers where they ask you to leave it in a fraction. You'll have decimal. You don't have fraction answers generally in further. Okay, so let's do this one. Now, it says the matrix equation below represents a pair of simultaneous equations. These simultaneous linear equations have no unique solution. So what does this mean, this no unique solution? No unique solution actually means that the determinant equals 0, and in other words, you can't get an inverse matrix, and equations can't be solved. Yeah? So if that's the case, so they're saying in this scenario, if they want it, so it cannot be solved. So that means the determinant of this matrix has to equal 0. Yeah? Yeah. So remember, how did we work out the determinant? Remember we did AD 12 times 3 minus 9 times m, and we have to say that equals 0. Okay, so then you've got 36 minus 9m equals 0. So if you're not very good at equations, I encourage you just to use your solve function. That's fine. And what do we get? We get m will have to equal 4. So there's my answer. If I want that not to be able to work, m has to equal 4. Okay, now the next example is where they give you the simultaneous equations in words. So a worker can assemble 10 bookcases and 4 desks in 360 minutes, and then he can do 8 bookcases and 3 desks in 80 minutes. If each bookcase takes B minutes to assemble and desk D minutes to assemble, the matrix BD will be given by. So if you look, we could set this up as simultaneous equations. I could say 10B plus 4D has to equal 360. That would be the first equation. The next one would be 8B plus 3D equals 280. So there's the simultaneous equations. If I was to set that up, it would look like this: 10, 4, 8, and 3 times the unknowns, which were B and D, and equals 360, 280. Okay, but they want to know what this actually equals. So if I was to do B and D, it would be the 10, 4, 8, 3 to the power of -1 times 360, 280. So go and have a look. Have they written? They haven't put it in that form, have they? No? No. So we probably need to find out the inverse of this. So we're going to find out what this bit actually equals. Yes? So we'll do that on our... So we worked out the inverse is actually that. So can we see this answer anywhere? Yeah. Yeah. So 3.5 is the same as... so -3/2 is the same as -1.5. So you can always do Control-Enter. So can you see how they don't use fractions, but our calculator was on exact. So here's the answer. Okay, this next one. It says the systems of 3 simultaneous linear equations above can be written in the form as. Okay, so there is actually 3 unknowns here, and so we're going to have a 3 by 3 to begin with. So our setup will be the 3 by 3. And remember, this will be all the x, this will be all the y's, and this will be all the z. So then I'll have times x, y, z, and equals the answers. So I'm going to say 8, 0, and 4. Okay, if you don't have any x's, you put a 0, okay? So now, what's the number in front of y for that first equation? 1 and then -1. Be careful, that's a minus. So in the next one, we have 5, -1 and no z's. In the last one, we have a x, no y's and a z. Okay, so is that one set up anywhere?
Yeah, B.
Is that correct? Yep, so B is the answer. Okay, this is not asked a lot, but just to explain to you, so when we set up the simultaneous equation, so say when we're solving it, so I'll just use the 2 by 2. So we set it up like this, remember, and we're solving it like that. So what happens if this determinant equals 0, then we can't solve the equations, yeah? Okay, so what's happening there is that means there's no, so we say, they often say there is no unique solution. So what they mean by that is when you have simultaneous equations, so if we just think about the graph, when you have your two equations, say one equation was that, the other equation was that, if you graph it, this is that unique solution. That's what you're solving, yeah? You're finding that spot where they both are the same, yeah? So if that's not happening, which is this scenario, if that's not happening, then it's going to be doing something like this. It means they're parallel, so they never cross, or they're actually the same line, it's just written, the same way. Yeah, you just multiply, it's the same thing. So it's not tested too much, but just so you know what it means when they say unique solution, it's that. So if there's no unique solution, the determinant will equal 0. So here, you just remember, so no unique solution, det equals 0. So if you want to write, maybe just summarize, that's really what you need to know. There's no unique solution, the det equals 0, okay? So with this example up here, we had the simultaneous equations. When they worked out the det of this front matrix, they found, it says state whether there is a unique solution for this equation. So you don't have to say what it is, you don't have to solve it, you just have to say, can it be solved? So what they did is they just put this into their calculator, det, comma, and like that, and they found it, and they said, see, they found it to equal -24. Because it isn't 0, there must be a solution, okay? So if it was 0, we'd say no solution. Any other number is fine. We'll practice what we're just talking about there. The matrix below represents a set of simultaneous equations. So one of these equations could be, so what they're doing is they want you to go backwards. So if you think about it, remember when we were solving, if we do multiplication, we go row by column equals that. So I could say 2x plus y, and there's no z, 0 times z, equals 3. Now if I did this row by this column equals that, then this one will be -3y, because there's no plus z equals 2. And if I did the last one, the backwards way, that row by this column equals that, it would be -x plus 2z equals -6. So which one of them is in there? Is there any? B, -3y plus z. Yep, that's one of the answers. So there you go. That's one of the ones I had. So there's that one. Now, below it says, the 4 matrix below represent a set of simultaneous equations. The number of these simultaneous equations which have a unique solution. So if they have a unique solution, the det will not equal 0. So let's go work out the determinant of all these. So the det of this one, say this matrix, 6, 3, 2, 1, that would equal 6 times 1 minus 3 times 2, which equals 0, doesn't it? So this one has no unique solution. Let me do this one. The det of this would be, remember, it'd be 1 times 1 minus 1 times 1. So what does that one equal? 0. So no unique solution. Let me do this one here. So det of 2, 1, negative 2, and negative 1 would equal 2 times negative 1 minus 1 times negative 2. So that's going to be negative 2 plus 2, 0. So that one has no unique solution. And I'll just do this last one down here. So the det of 3, 6, 2, 4 would equal 3 times 4 minus 6 times 2, which is 0. So how many have a unique solution?
Not one of them.
Not one of them. So there's the answer. Okay, let's go. The basketball coach has written 3 linear equations which can be used to predict points, rebounds, and assists that Oscar will have in the next game. These equations can be written equivalently in matrix form. Complete the missing information. So here you just have to write the numbers. So it's 1, 1, 1, 2, negative 1, 3, and 1, 2, 1. Okay? Now, down here, they've said this is the setup. So this is actually the inverse here. And they have left that one as an X, and they want you to find that out. So you pop it in your calculator. So what you're going to do is you're going to pop this first one in your calculator to the power of negative 1 and see what it is. Because it's going to be 7, negative 1, negative 4, and you're going to be able to see this missing answer. Alright, so we find that this is negative 5, so x equals negative 5. And then how many rebounds? So you're just going to work that out and times it. You'll get an answer for your P, R, and A, but you only have to quote what the rebounds is. So rebounds equals.
I'm going to get you a double. I'm going to get a lot of boards. What do you reckon, Harry?
What was it?
No, what
Have you done it on your calc? Just do times the last 33, 40, 43. Do that matrix that you just found. Times it by the 33, 40, and 43. Yeah, the end one. Yeah. Ben's going to do it.
40, 43.
What was our answer?
19, 10, and 4.
19, 10, and 4. So rebounds. Rebounds is?
10.
10.
14. 4. This is, he needs to pass the ball more. That is hog.
You right, Harry?
Yeah.
No? Alright, guys, go start 12B. I'll do them next lesson. Everyone's a bit unsettled. I'll do some more going over it.
Yeah, you take double. It's a deal in your 18 game. Could be better. It's like 50 on my
You can, tomorrow I'll do the last ones and you can work on 12B in tomorrow's class, okay? Because I've taken up half the lesson. You're not supposed to be wandering. No, they're telling me off. The teachers, because year 12s are not being wandering around the rings. Sit down. One can go to the toilet. When the bell goes, go fill your bottle up in between. Pardon? Oh, so, because it's a rule. Just one, you can go, but not the whole bloody committee.
Is it Mr. Toll that's telling you this?
Oh, it's just whoever it is. So, sorry, Ben, did you book that? What do you want? Okay, 5:15. I'll send you the thing. Yeah. Yeah. Sorry? Oh yeah, I'll go get that. Alright, I'll quickly get that.
Oh my god, I'm first. Of course first.
On what? Reading.
Yeah. Wait, yours is today? Yeah.
Josip, you knock it out of the ballpark.
Psych.
Yeah, that's really good.
That way he stays safe on the road. And man.
Mostly man. Yeah, well, obviously.
Tesla. Just 12B?
Yeah, it's not big. It's not like you get off to anymore. Isn't it not safe?
Done tonight?
No, you won't.
Face of a man, you do what? Yeah, shut up.
Never.
Trump Ben heard him from Twitter. For 2 years on Facebook. Yeah, that's yeah, raising eyebrows.
That is colossal. It says Addison Ray said hello to him at the UFC fight.
Addison Ray, have you seen
Addison
Addison
Ray was.
They definitely shagged up.
Addison Ray would love
Look at that fake 10 together before it. I was more talking about me, that was the more joke. And you're saying the morning members of parliament.
Send it out to the library. Pardon? Yeah, but it's not stapled. I'll just give Ethan, wait a minute. Holiday revision. File, print, library. So, if you want to go now, did you want to pack up and because the bell will go, and it'll be in the library, black and white. And I will now looking to send Ben that thing. Yes.
Ooh, I follow. Wait, am I? I'm thinking my speech.
Who's not here? Seb's not here? And Nick's not here? Fair.
Bad.
You are the best player playing on
Bad.
detrimental to your attack.
The random thing. There was random, she's like a random like spinning the wheel.
Yeah. Nah, it's actually not. Because they're going to be thinking about your one the most and how bad it is. How bad. They're going to be like, that's so bad.
They're gonna be like,
Bad.
really like, that's so bad. Like, yeah, bad.
Bad.
Bad. All the times are bad.
Boy, they're going to be like, oh, you're bad, baby.
There's something very sneaky.
Bad. As Jojo was. Nah, I respect that. Nah, because the English teachers, they're gonna love that.
Anyone else
Emma did not read
miss the
Emma.
parent-teacher interview?
I didn't know.
That you like to book it?
I think that is.
Yeah, Marco. Yeah.
Not the actual working that day.
Miss, I believe I did.
All right. Have a great day. See you at basketball. Pardon? Oh. No, I haven't marked it. Did you do it today? Did you give it to me today? Yes. Yeah, I haven't marked it. I'll mark it and then I'll give it. I can give it to you at basketball if you like.
What time are we leaving today?
I popped it. What? No, we're at 1:30. We're at home.
1:30.
Are you? You're not on the team.
So we're leaving before the bell?
No, it's at 1:30. So lunchtime.
1:30 to 2:30. No, do we leave before the
Oh, if you're finished.
end of school? End of school.
If you're finished, yeah.
Oh, bloody hell.
100%. Okay, so which of the following systems of simultaneous linear equations best represents the matrix equation above? So we saw yesterday when we were doing these that when you're setting up simultaneous equations that these are the numbers or the in front of your letters or your coefficients. So this will be all the V's, this will be all the W's, this will be all the X's, and this will be the Y's. And this bit here will be what the equations are equal to. So I could pretty much write them out again. I could say 2V plus 2W minus 2Y equals 2. Yeah? So I've done the first line. The next one would be 2V minus 2X equals 6. So when there's a 0, you don't need to put anything. The next one would be 2W minus 2Y equals -8. And the last one would be 2V plus 2W minus 2X equals 4. So what you're doing is you're looking for the multi-choice that has all of them listed out, which I believe, to me, no, which one is it?
B.
B? Yep. Looks good?
Yep.
So B. Okay, question 5. Liam cycles, runs, swims and walks for exercise several times a month. Each time he cycles, he covers a distance of C kilometres. Each time he runs, he covers R kilometres, swims S kilometres, and walks W kilometres. The number of times he cycled, ran, swam, or walked each month over a 4-month period, and the total distance he travelled is given in the table below. The matrix that contains the distance each time Liam cycled, ran and walked is that. So is this, and so therefore, and what you need to work it out. So really what you would look at is that these would be, you could set this up as a matrix, yeah? And then we would be timesing it. So if he cycled say 5 times a month, remember how far he cycles is C kilometres, and that's what we want to know. So if you times this matrix by that C, R, S and W, what it would equal would be this last one here. Yeah? Sorry, I'm just like squeezing it in there. Okay, so you can see it's like simultaneous equations, yeah? So what I will do is I would find the inverse of this one, yeah? So say I call that matrix A. I'm going to go matrix A to the inverse, and I'm going to times it by this end matrix here, yeah? So I might just call that E for you. So to times it by E, and that's going to give us this answer there. All right, so let's go do that on our calculator.